Okay, 6.2, apply properties of rational exponents. Okay, do you remember the properties of exponents by chance? There are 6 of them. So let's walk through them very quickly, and then that's what we're going to be practicing today. Okay, if you have properties of exponents, the bases have to be the same for things to happen, yes? Okay, if my bases are the same, what do I do with my powers? Nope, you add. If the bases are the same, you add. So if I have 5 to the 1/2 plus 5 to the 3 seconds, I'm adding 1/2 and 3 seconds, which would give me 4 seconds. And what is 4 seconds? 2. So then I get 5 squared, which is 25. You're going to work it all the way out into simplest form. So you add exponents, you simplify the exponent, and then if you can go from there, you keep going. Okay, we're doing it with fractional exponents today. We've done this already this year with regular exponents, with whole numbers. We're doing fractions now. Okay? What happens if I have a power raised to a power? What's the rule of a power to a power? You multiply. So if I have 3 to the 5 seconds squared, okay, I'm multiplying 5 seconds and the squared part. So I'm doing 2 times 5, okay, because technically this 2 has a 1 under it, right? So I do 2 times 5, which is 10, divided by 2, and I get 3 to the 5th, and then you tell me what 3 to the 5th is, which is 243. Okay? What happens if I have something inside parentheses and then have an exponent on the outside of that? What do I do with that exponent? Distribute it to both portions. So I have 16 to the 1/2 and 9 to the 1/2, which means I have the square root of 16 and the square root of 9. So the square root of 16 is 4, the square root of 9 is 3, and 4 times 3 is 12. Okay? If I have a negative exponent, what do you have to do? You flip it, put it on the bottom. So I get 1 over 36 to the 1/2, and what's the square root of 36? 6. So you get 1/6. Okay? If I have the same base and I have a fractional with exponents, what do I do with those exponents? What do you do when you have a fraction? You do what with the exponents? Subtract. So I have 4 to the 5 seconds over 4 to the 1/2, so 5 seconds minus 1/2 is 4 to the 4 seconds. 4 seconds is 2, so you get 4 squared, which is 16. And if that came out to be negative up top, instead of saying 4 squared, if it said 4 to the negative 2, what would you have to do from there? Flip it back. Okay, good. And once again, if I have a fraction in parentheses with an exponent, I distribute both portions. So I have 27 to the 1/3, and I have 64 to the 1/3. Taking the cube root of 27, which is 3, and the cube root of 64, which is 4, and you get 3/4. You are going to simplify everything as far as you can. You understand? Okay? These rules are not anything new. They're the same rules, you just have fractions in your exponents, so don't freak out. You are more than capable of adding and subtracting them, and you're more than capable of switching them into radicals so that you can solve. I'll give you a second because L is still working. No, you're fine, I'm just checking. Shocker, shocker.
Bless your soul.
No, bless you. We're going to have lots of examples with 7 more slides, and they're pretty much all examples for the most part. Okay, so we're going to go over a lot. So, if I have 5 to the 1/3 times 7 to the 1/4 cubed, how would I start to solve that? What do you need to do? Distribute the property first, right? So what's 5 to the 1/3, which means 1/3 times 3? That would give me 5 what? To 5 to the 1, 5 to the first. So I get just 5 or 5 to the first. And what happens when I have 7 to the 1/4 cubed? 7 to the 3/4, okay. 7 to the 3/4. Can I do anything from there? Nope. That's as far as you can go, right? I can't do anything else at this point. Okay. What else? Let's look at the next one. You have 2 to the 3/4 times 2 to the 1/2. What do I do with those exponents? Add them. What do I need to do first before I add them? Same denominator. So let's change 1/2 to 2/4, yes? Okay, so if this is 2/4, then I have 3/4 plus 2/4, which is what? 5/4. Okay. So you get 2 to the 5/4. Can I take that any further? Is there a fourth root of 2? No, because 2 is what times what? What makes up 2? What do you multiply? Yeah, so is there a fourth root of 2? No. Okay.
No.
What do I do on the next one? You have 3 over 3 to the 1/4. Yes, you can. What is always with that 3? A 1. So what can you do? 4 over 4, and then what am I doing with that?
Subtracting.
Yes, so you have 4 over 4 minus 1/4, right? And you end up getting 3 to the 3/4, correct? Okay, 3/4
Is that a multiplier or no?
minus, sorry, it should, minus, okay. And then on number 4, you have 20 to the 1/2 cubed over 5 to the 1/2 cubed. What are you doing with that? Distributing first, okay, so then you get 20 to the 3 seconds, right? On bottom, you get 5 to the 3 seconds, correct? Okay, can I take that any further? Yes, what can you do? Do they have the same base? 20 and 5 are the same base?
Oh.
Can I get 20 to the same base? Okay, what goes in, how would I, Elsa's, yeah, so let's take a look. 20 is 2 and 10, right? And 10 is 2 and 5, correct? So you would have 2 radical 5, right? 2 radical 5, then this would all be to the 3 seconds. And down below, if I switch this, I get radical 5 cubed, correct? Is that true?
Did it have the radical 5 on the bottom?
Because this is 3 seconds, which
Oh,
means
yeah,
it's the
yeah,
square root of 5.
Gotcha.
So then, what happens with that? What happens from there? Subtract what? Okay, I can possibly subtract the exponents. So let's say we subtract the exponents, that's 3 seconds and 3, right? 3 seconds minus 3. So 3 would be over top of, well, 3 seconds and 3. How would you make that so you can subtract 3 seconds and 3? What would I do to be able to subtract that? 6 seconds? So if I do 6 seconds, right? What do you end up getting? What's 3 minus 6? Negative 3? Negative 3 seconds, right? What?
You get 6 seconds.
So that's hard that way, right?
Since 6 divided by 2 is 3.
Right. I changed 3 into a mixed fraction that represents 3 still, but with the
Like
donut.
6 seconds.
That's what I'm telling you.
6 seconds equals 3.
Because on the bottom you have radical 5 cubed. So to change that cubed into a fraction, you have to multiply it by 2, and you get 6 up top and you get 2 on the bottom, 6 seconds, so that they're the same denominators. You need the same denominators put them together. Now, that's a little bit messy because now I have a negative radical exponent, correct? Okay, so let's start over and see if there's a different way you can do this. Because you can do it that way, but that gets a little bit messy, right? So, what happens here from the beginning? In order to do anything, you need the same base, yes? Okay. And we've decided that that base would be 5, okay? Or, what I can do from the beginning, bless you. What I can do from the beginning is maybe do something else like this. What happens if I change this into the square root of 20 from the start? And change this into the square root of 5 from the start? yes? And leave that cube there. 20, we decided comes out to be this, correct? What happens now? What can happen with those radicals? They can cancel. So then I get 2 cubed, right? And what is 2 cubed? 8, and that's your answer. Sometimes changing things into the radical form makes your life easier. Sometimes. You've got to be able to play back and forth with that. Does that make sense? Okay? So when I see one like that and they don't have the same base, I say, hey, let's change it to the radical and see if we can work with that.
I'm so scared, I thought we were gonna have to do that whole thing, and then every single
Yeah.
time it's something like.
No, because you got that negative, which means then you have to flip it, then you have to get it out of the bottom, right? Because you can't have a radical on the bottom. So you'd eventually get to 8, but it would take way much more work. Way more work, okay? So if we do it that way and change it into radical form first, then sometimes we can break down the radicals so that they're the same bases and we can then get rid of stuff, which makes life a lot easier, yes? Okay. A mammal's surface area, S, in square centimeters can be approximated by the model S equals K times M to the 2/3, where M is the mass in grams of the mammal and K is the constant. The values of K for some mammals are shown below. Approximate the surface area of a rabbit that has a mass of 3.4 grams. What do I need to do there? What do I need to do?
It's 3.4 kilograms, so.
3.4 kilograms, right, but look at what they gave you down here. What's in parentheses? Scientific notation. Okay, but it's in grams, right? So it's transferring kilograms to grams. Okay, so how am I gonna plug in, what am I gonna do?
There's 1,000 grams and 1 kilogram.
No one needs that information.
Chemistry does.
What are you gonna do? What animal are you focusing on? So do you need the other information right now? No. And what is the mass of a rabbit?
4 kilograms.
What is it?
3.4 kilograms. Oh, 9, sorry.
Wait, yeah.
9.75.
9.75 is the value of K, correct? Okay. So what do you think I should probably do with 9.75?
Plug it in for K.
Plug it in for K, so that you have S equals 9.75. Now, what is the mass? How do we figure that out?
3.4 times 10 to the 3rd.
Good. 3.4 times 10 to the 3rd. And then this is also raised to the 2/3, correct? In the equation, the mass is raised to 2/3.
Yeah.
So how do I solve from there?
Distribute
Distribute the 2/3?
the weight, yeah.
Yeah, you're right. So you get 9.75, and then you would have times 3.4 to the 2/3, yes? Times 10. And what happens when I do 3 times 2/3?
2.
2, because 3 times 2 is 6, divided by 3 is 2. Great. Now what would you do from there? Just, yeah, plug it in your calculator and multiply. Okay? So use your exponential button, multiply. Cool? Don't make it harder than it is. Now, properties of radicals. Yes, ma'am.
So if you're doing a exponent that's a fraction,
You have to put parentheses around it. Okay. Properties of radicals. Product property of radicals. If I have the nth root of a times b, I can separate that out to take the nth root of a and then multiply it by the nth root of b. Because sometimes when I multiply those two numbers together, it's not going to have that 6th root or whatever. But if I do it individually and then multiply them together, it's going to work. Does that make sense? So you're going to have to be able to go back and forth. And the same's with the quotient property, which this is nothing new.
Please excuse this interruption. Carson, Satimo, and Jackson Raby, please go back to the cafeteria.
So the quotient property of radicals is going to do the same thing. If you take the nth root of a over b, okay, you can separate it out to take the nth root of a and then divide it by the nth root of b. Because once again, it's about which way does it work easier for us. So you're going to go back and forth between those two things. That will come with time of practice. You'll start to recognize those easier, okay? So it can be a little frustrating at the beginning, but it's not a difficult concept, it's just recognizing numbers. The better you are with numbers, the easier this is going to be for you. The better you are with multiplication facts, the easier this is for you. Okay, so the fourth root of 27 times the fourth root of 3. First of all, can I take the fourth root of 3? No, so do you think I want to combine those together? Yes. Okay, because let's be honest here. 27 breaks down into what? 3 and 9, and 9 breaks down into? So how many 3's would I have between the two of those three things? So what is the fourth root of 27 times 3? 3. Okay, the cube root of 250 over the cube root of 2. Okay, does 2 have a cube root? No. Okay, this is some like common sense ones. 2 does not have a cube root, correct? So how could I solve that then?
250 over 2 with a cube root around the dome.
Does 250 have a cube root?
Huh?
I said, does 250 have a cube root?
Probably.
You said probably? Well, I'm not the one that needs to do this math, you are, so let's see. Why don't you guys grab some calculators and try some stuff out?
It does have one, but it's messy.
Okay, I mean a clean one. I need clean. Okay, so it doesn't have a clean one, correct? Okay, so why don't we rearrange this, okay? Why don't we rearrange it the way it shows us like this, right? And take the cube root of that whole thing, you know what I'm saying? What is 250 divided by 2?
125.
Does 125 have a cube root?
Yes.
5. Now do you see why we have to be able to work those back and forth? Okay. The fifth root of 3/4. Ooh. Does 3/4 have a fifth root? No. I would definitely say no, correct? Does 3 have a fifth root? Does 4 have a fifth root? No, but if we break it down into the fifth root of 3 over the fifth root of 4, what do you know that you have to do with this denominator spot? You can't have radicals, right? Okay, so what would I multiply this bottom spot by, okay, in order to get a fifth root of 4? Like, what number would give me 4 4s? You know what I'm saying?
16.
No, 16 gives me 2 4s. 3 4s, right? 64? How many 4s are in 64?
There's 3 4s.
There's 3 4s in 64, so that only gives me 4 total, correct? So not 64, but what's 64 times 4?
256.
So 256. So if I multiply this by the fifth root of 256, and I multiply the top by the fifth root of 256, this is what you end up getting. You end up getting up top the fifth root of, what's 3 times 256? 768 over 4, right? Because there is a fifth root of 4 and 256 together, correct? Okay. So then, do you have a fifth root of 768? If not, you can leave it this way, it's fine. Or we can break it down factor tree wise. Okay, once again, you want clean, 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 okay? So what you would technically do is take 768 and pull stuff out of there, right? 48 and 2 is 24, right?
Mhm.
And then you would have 1, 2, 3, 4, and you would get 24, so you would have 2, the fifth root of 24, because 24 doesn't have a fifth root, over 4. And then these do what? Just 2 and 4 do.
Wait, how do you get 24?
48 divided by 2 is 24, yes?
Yeah, but then.
You have 1, 2, 3, 4, 5 2s. 24 doesn't have a fifth root, so I stopped there. I just stopped because I knew it didn't have a fifth root. And then the 2 and the 4 would then reduce down, yes, to be the fifth root of 24 over 2. So, answer. If I want to add radicals together, what has to happen with them? What?
Wait, no, that's not.
Well, I can't hear what you're saying, and I think you're right.
I said same base, but it was.
The same base, but what's the base in a radical? The inside. So can I get 40 to have an inside of 5? Yes, if I factor tree 40, what do you get? 5 and 8, and what do you get from 8?
2 and 4.
2 and 4, and then 4 is,
2.
so what am I taking outside of that?
2.
2. So you have the cube root of 5, right? Plus 2, the cube root of 5. Now they have the same base, or the same insides. What is the cube root of 5 plus 2, the cube root of 5?
Squared.
Nope. What technically is in front of this cube root of 5?
1.
A 1. So what's 1 plus 2?
3.
3. Do you add the insides?
No.
No. So you get 3 the cube root of 5 as your solution, as your answer. You gotta start being able to play with numbers. Gotta play with numbers. Basically this is saying when it's odd, okay? If the powers are the same here on the outside and inside, if it's odd, it equals x. So if it's the 7th root of 5 to the 7th, it equals 5, okay? And if it's the 7th root of -5 to the 7th, it equals -5. The exponents cancel, the inside exponent cancels the radical out. Here, if you have the nth root of x to the nth power and it's even, meaning it's 2, 4, 6, 8, you're taking the absolute value of what x is. It always has to come out positive. It can't have a negative come out of a radical that is an even root, okay? Has to come out positive. So if I do the 4th root of 3 to the 4th, it's 3. And if I do the 4th root of -3 to the 4th, it's 3. It has to be positive answer. Because when you're taking the 4th root, you have -3 times -3 times -3 times -3, right? Or 3 of those, or 4 of those, which would make a positive answer. So, we get to this. Let's start with 10. The cube root of 27, q to the 9th. Okay, take this one step at a time. So start with 27. Does 27 have a cube root? What is it? 3. Okay, 3. Does q to the 9th have a cube root? Now here's how you do these ones. When they are variables with a power. You want to say, how many times does 3 go into 9?
3.
Well, what did you say? What times what gives you 9? 3 times 3. So how many sets of 3 can I take out from there, basically?
3.
3. What?
I was at 2.
Look, you have this. You have 9 Q's, yes? 4, 5, 6, 7, 8, 9. How many groups of 3 can you make?
3.
1, 2, 3, correct?
Yes.
So when I take it out, I get Q to what? When I'm taking the cube root of 27 Q to the 9th. When I took the cube root of 27, you told me it was 3.
Yes.
When I take the cube root of Q to the 9th, what do you get? Q cubed. Q cubed. Because I could take 3 sets of 3 out.
Yes.
That's how I get that.
Oh.
Q cubed. 3 sets of 3 out. Okay? What about this? X to the 10th over y to the 5th. How many sets of 5 can I take out from x to the 10th? 2. And how many sets of y's can I take out from y to the 5th?
One.
So you just put it over. Oh, this should say 2, not 5, sorry. So this should just say y. Okay. Look here, we're gonna reduce before we do anything. What's 6 divided by 3? 2, okay? Always cancel out first. Now, you have x and you have x to the half. What do you do with those exponents? You what? Subtract, so what's 1 minus half? So you get x to the half, correct? And then you have 3/4 and you have 1/2, so you're supposed to subtract them, right? What's 3/4 minus a half?
1, 2. Oh, no.
So it's 3/4 minus 2/4, 1/4. Y to the 1/4. Solution.
You have to change the 1/2 bottom to 1/4
Correct. To 2/4.
to 2/4.
To 2/4, because you have to have common denominators. Okay, now over here. Can I subtract these yet? Are the insides the same? No. So let's start by taking the square root of 9. What is that?
3.
3. And then let's say, how many sets of 2 can I take from w to the 5th? How many groups of 2 can I take out?
2.
Okay, sort of. You have this, right? And you are correct. I can take out this set and I can take out this set, but there's only one left inside, yes? The problem is, what do I need left inside?
2.
No. What's on the other one inside? 3. So how many sets can I take out so that I can still subtract them from each other? 1. So I'm just going to take out a w, yes? Okay? And then you have y cubed still inside. Does that make sense? Okay? And then you're subtracting from it w cubed. Now, I can subtract this because this is a 3w and this is a what? So what's 3w minus w? So you get 2w, w cubed. So even though I could have taken out 2 sets, you have to pay attention now to what's in the other one so that they're the same. Okay? So sometimes be careful and aware of not taking it too far. Oh, that is it. Okay? That is why tomorrow we will also be doing the same thing before your quiz on Thursday.